Assalamualaikum warahmatullahi wabarakatuh. Good day, ladies and gentlemen. My name is Aulia Fikri Dayat. I'm from the Department of Pharmacy, Faculty of Mathematics and Natural Sciences, Universitas Islam Bandung. Today, I'm going to talk about our study entitled In Silico Coformer Screening for Mefenamic Acid Cocrystallization. This presentation is a complement of the article submitted in a Science and Technology Research Symposium 2023. Okay, now for the main presentation. I'll start with the background of our research. It is widely known that the solid crystalline active pharmaceutical ingredients, or APIs, or solid drug are still suffering from limited solubility, which subsequently causing lower bioavailability and thus limiting its therapeutic potential. Modification toward that kind of drug, such as by formation of cocrystal, may overcome these problems. A cocrystal typically composed of a solid API and a supplementary compound which is described as the coformer, and they interact via non-covalent intermolecular interaction such as hydrogen bonding, van der Waals force, or pi interaction. In cocrystal formation, the role of coformer is essential. Therefore, selection of suitable coformer for specific drug is a crucial step to predict cocrystallization. And in this study, we utilize a computational approach, particularly via molecular docking, as a coformer screening method. And then we also use mefenamic acid as the model drug for our cocrystal formation. Mefenamic acid, according to the biopharmaceutical classification system, possess low water solubility, so the modification toward co-crystal form is a viable option to enhance its solubility and the dissolution rate. So the main purpose of the study is to explore the interaction between mefenamic acid and several compounds as coformer candidates using molecular docking approach. And to achieve this, several steps of molecular dockings were taken accordingly. And for the final step, we would observe and compare the interaction type and the binding energy of the mefenamic acid and its coformer candidates. And for the first result, according to the molecular docking result, it is observed that the majority of the compounds were able to generate hydrogen bonding interaction with mefenamic acid, except for stearic acid and succinic acid. It is also worth noting that in conventional synthesis, the presence of hydrogen bond reflects the stability of a cocrystal due to complementary pairing of hydrogen bond donor and acceptor moieties. Thus, it is more favorable for a cocrystal structure to have such interaction. The next result illustrates a closer inspection of hydrogen bonding in sampled interaction of mefenamic acid with saccharin and mefenamic acid with nicotinamide. It is showed here that the hydrogen bond in both systems were resulted from the interaction between the amide, the NH part from the coformer, and the oxygen of the carboxylic acid in the mefenamic acid. And then the final result is the energies of involved interactions in mefenamic acid coformer systems. Delta G estimated the free energy of binding. E intermol represents the final intermolecular energy, and EVHD represents the energy of van der Waals interaction plus hydrogen bonding interactions plus disolvation. E elect is the electrostatic energy, E total is the final total internal energy, and E torsional is the torsional free energy of the systems. It is observed here that the intermolecular interaction between mefenamic acid and Coformer compounds is dominated by EVHD, as indicated by mostly higher negative values. This signifies the contribution of non-covalent van der Waals and hydrogen bonding to the formation of co-crystal. Additionally, more negative delta G result indicates more energetically favorable system, which subsequently demonstrates more spontaneous process due to lower energy of formation. And the analysis of binding free energy also offers a quantitative approximation toward the stability of co-crystal system. It can be seen here that the mefenamic acid interaction with the saccharin generates the lowest binding free energy with the value of minus 3.10 kilocalorie per moles, thus offering possibility of a stable co-crystal formation. So it can be concluded that from docking result, it is revealed that the majority of Coformer candidates were able to form interaction with mefenamic acid via hydrogen bonding and pi interaction. And also, based on calculated binding free energy, saccharin with the value of minus 3.1 kilocalorie per moles had the most optimum binding affinity with mefenamic acid, indicating the possibility of stable co-crystal formation. I think that is all for my presentation. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.